Good morning, everyone. My name is Islam Youssef. I'm Associate Professor of English and Linguistics at the University of Southeastern Norway. And today I'll be delivering one of the very few theoretical, non-experimental talks at this conference. The title of my talk is A Factorial Typology of Superheavy Syllables in Cairene Arabic, English, and Hindi. So let's get started. A long-standing issue in phonological theory is how to represent superheavy syllables, syllables of the shape which surface as CVCC with a short vowel followed by two consonants, or CVVC with a long vowel followed or diphthong followed by a single consonant. Such syllables behave differently across languages, both in relation to their distribution, having unrestricted distribution or occurring only in word final position, or in relation to their weight, behaving either as heavy or as extra heavy. My paper explores how the final consonant of superheavy syllables is parsed in three languages: Cairene Arabic, English, and Hindi. The outline of the talk will be as follows. First, I'll lay out the basic tenets of Moraic theory, which will serve as the representational framework for my analysis, and then I'll provide the facts of superheavy syllables in these languages and how they're interpreted in the Moraic approach. And finally, I'll offer an analysis within optimality theory, demonstrating how the ranking of only 5 constraints determines language-specific characteristics. So let's start with the Moraic theory. Moraic theory posits that only moras are present on the prosodic tier. Moras have two major functions. First, they represent the contrast between a light syllable and a heavy syllable. And second, they occupy a phonological position, which may be doubly linked to long or multiple segments. The main rules for assigning Moraic structure are as follows. Long vowels have 2 moras, short vowels have only 1. Short consonants do not bear a mora unless assigned 1 by rule, and geminate consonants bear 1 mora underlyingly. An important claim of the theory is that languages can assign Moraic structure differently. For example, a CVC syllable can be heavy in some languages and light in some other languages. The above rules are also supplemented by a principle of weight by position, based on which coda consonants may be assigned a mora and thus become heavy in the default assumption of the weight by position principle is that syllables are maximally bimoraic, and trimoraic syllables also exist in some languages. So now we start with the facts in Cairene Arabic. There are 3 basic syllable types in this language: light syllables, CV syllables, and heavy syllables, which can be CVV or CVC, but only when these syllables occur word internally. The language also has super heavy syllables of the shape CVVC or CVCC, but only in domain final position. So they are restricted in terms of their distribution. As we see in these examples here, super heavy syllables attract stress. They're heavy, they're stress bearing. As we see in A, all the final super heavy syllables seem to have stressed, and this is exceptionless. They're also prosodically heavier than CVC syllables, which do not seem to be heavy in final position, as we see in examples B, where they don't attract stress. So my proposal is to represent super heavy syllables as bimoraic in Cairene, with the final consonant being syllabified as extra syllabic here, so linked directly to the prosodic word as we see in this diagram, since it's parsed outside the syllable as well. So it doesn't add any weight to the syllable itself. Moving on to English, There's a wide range of syllable shapes in English along the well-known formula C nil to 3, V nil to 4. Unlike Cairene Arabic, superheavy syllables in English have unrestricted distribution. They occur word finally, inward internally, in simple, complex, and compound words, as we see in some of the examples here, words like pulse, greenhouse, princehood, and so on. They also count as heavy in terms of stress. So if they are penultimate, as in the word unhelpful, they will attract stress. And also in the exceptional cases where they are final, they would also get stress, as in the word brigade. So I propose that these syllables are also bimoraic in English, but here the final consonant will share a mora, which will be a branching mora, meaning that the mora will be shared with a preceding segment. In words like elm, here we see in the diagram where the mora for the final consonant is shared with a preceding consonant, or in words like feel, where the mora is shared with a preceding long vowel. So moras in English are branching. That's my assumption. Now, moving on to Hindi, there are also 3 syllable types in this language: light syllables, CV, heavy syllables, CVC or CVV, and super heavy syllables. And there is a 3-way length distinction in which super heavy syllables seem to be heavier, behave heavier in terms of attracting stress compared to heavy syllables. And also heavy syllables attract stress more than light syllables. So there is a hierarchy of syllable weight according to Hayes, in which we can say that light syllables are monomoraic, heavy syllables are bimoraic, and super heavy syllables are trimoraic. And this is the only way to distinguish and explain stress facts in Hindi, as we see in these examples here. If we have a word with a trimoraic syllable, as in the word Muslim here, Musulman, with 3 moras, the 3 moras would always attract stress, so it's heavier than a bimoraic syllable. And if there's a tie, then the stress will go to the rightmost non-final syllable. So here we have no way of explaining these facts except by assuming that super heavy syllables are trimoraic in this language. So the final consonant will always be assigned a mora to mark superweight, as we see in this diagram here. The final consonant has 3 moras. Now, introducing the constraints in optimality theory, these are all viable constraints that will be relevant for my analysis. The first constraint is star 3 moras, which simply says syllables should not have 3 moras. They're maximally bimoraic. The second constraint is no branch, which says that that moras are not branching, so we should not share moras with preceding segments. The third constraint is parsed segment, which penalizes unparsed segmental material, meaning that all segments must be dominated directly by the syllable. The fourth constraint is mora to consonant, which states that each consonant in the rhyme at the peak or the coda has to be linked to its own mora, whether that mora is shared or separate. And so all segments have to be fully syllabified and linked to moras. The fourth and most important constraint is weak edge, which states that the right periphery of the prosodic category should be empty. Now, the prosodic category in the formulation corresponds to any prosodic category, so the prosodic word, the syllable, or the mora, and we assign 1 violation mark for each link between the final element and the top of the prosodic hierarchy. So we see here in this table that a final consonant that is directly linked to the prosodic word, candidate D, where there's only 1 line linking the final consonant to the prosodic word, and therefore there's 1 violation of weak edge. In candidate C, we see that this consonant is linked first to the syllable and then to prosodic word. So we have 2 violations linking for these 2, corresponding to these 2 lines, 2 violations of the constraint weak edge. And then consonants which are assigned a mora, whether the mora is shared as in B or separate as in A, incur 3 violations of the weak edge constraint, 1 for each line linking that consonant to the prosodic word. Now let's see these constraints at work. First, the ranking for Cairene Arabic. We interpret the final consonant extrametricality or extrasyllabicity by ranking the constraint weak edge above pars segment in more to consonant, because we want to have as few links as possible for that final consonant. We interpret extrametricality by ranking no branch and *3 mores above pars segment. And then we see in this tableau the final ranking where any candidate that violates weak edge more than once is immediately eliminated. So we see that candidate A shares a mora for the last two consonants. It has 3 violations of weak edge. Same for candidate C, which has a separate mora, and they're both eliminated. Candidate D does not have a mora, does not assign a mora to the final consonant, but it's still linked directly to the syllable, so it has 2 violations. Now, the optimal candidate, candidate B, has only 1 violation of weak edge, and then another violation of the lower ranked pars segment. Moving on to English, we interpret branching moras in English by ranking mora to consonant in *3 moras above no branch. And exhaustive syllabification is interpreted as an undominated pars segment constraint. So pars segment dominates weak edge in this language. And we see here that also weak edge and no branch are violable and unranked with respect to one another. In this tableau, we see that any candidate that violates pars segment is eliminated. That's candidate B. A segment that is the final consonant is not parsed. Any candidate that violates mora to consonant is eliminated. That's candidate D. And any candidate that violates *3 moras, which assigns a mora to the final consonant, is also eliminated, and that's candidate C. So the optimal candidate here is A, the mora sharing candidate, which also violates weak edge multiple times, but this constraint is low ranked in this language. Finally, we have the ranking for Hindi. In this language, trimoraic superheavy syllables are favored to branching moras and unparsed consonants. So we have mora to consonant and no branch ranked above *3 moras. Pars segment is also undominated since we have exhaustive syllabification. And we see here in the tableau that candidate B, which parses the final consonant as extrasyllabic, is ruled out. Candidate A, which has branching moras, is ruled out by no branch. Candidate D, which has a non-moraic representation for the final consonant, is ruled out by mora to consonant. And the optimal candidate is candidate C, which has a trimoraic final consonant or final syllable. So to conclude, in this short paper, I hope to have provided support for language particular moraic structure, meaning that the final consonant of superheavy syllables can be parsed as extrasyllabic or non-moraic in some languages, as mora sharing in other languages, and as moraic in a third set of languages. Within optimality theory, constraint weak edge facilitates a unified account of the patterns, where a high ranking of this constraint results in parsing final C, final consonant as extrasyllabic, while a low ranking requires the final consonant to be syllabified. In optimality theory, we have one set of constraints, and only re-ranking these constraints yields various grammars. So I hope to have shown that how various rankings of these 5 constraints generate the factorial typology that we see here, a typology that explains the distinct behavior of superheavy syllables in these 3 languages. Thank you very much. These are my references.